Hey guys, so welcome to my first YouTube video. What we're going to be covering today is basically the fundamentals behind programming. So I'm really sorry, but unfortunately we won't be coding today. I'm just going to be getting you familiar with some principles. So when we do the lecture on how to program and getting started, you'll actually understand what I'm talking about. So in this video, I'll be covering things such as pseudocode, control flow, iterations, selections, and how to actually store variables. It's a concept that's really simplistic, and if you understand these things already, just skip this video and go to the next one. But just for everyone else who's always asked, how do I begin to program, or what are the things I need to know before I do any programming, this video is designed to help you program basically. I'm going to treat it as you're starting from fresh. A lot of people have asked me, how do I learn to program? But like, where do I begin? So I'm starting right from the basics of what makes a program, what are the concepts you should be looking for when programming, and we'll basically build from there. So the first principle I'm going to basically introduce to you is going to be called pseudocode. So what pseudocode is, it's a way of representing programming in English. Essentially, it's like a recipe, right? You list out what your objectives are for the program, the kind of things the program should do, and basically you can build from there. It's outlining what you need to program. It's the simplest form of, if I have a issue, say you want to make an application that checks if a number is greater or less than 0, is it a positive or negative number? Where do you begin in programming that? It's such a simple program, but you need to know where to begin. That's where pseudocode comes in. So the concept of pseudocode is you write it out just like you would like a recipe. If you're making a Victoria sponge cake or chocolate cake, you'd always begin with a recipe detailing what it is that you're building. So I'm going to start here. So first thing you write is obviously start. That's the start of my application, and that's as simple as that. So what's the first thing I want to do? Well, from you, the user, if you're using the application, I want to get the number. So I would write down get number. That's the first piece of code I should be writing for my application, is get number. I can tell you the code for that is more than a line. But then what's the next thing I want to do? Now, this is the idea of how would you say it? You would say if this number is greater than 0, it's a positive. If this number is less than 0, it's a negative. So I would write that out next. So you write if. We'll write out the full words in these examples. If greater than 0, do something. So what do I want it to do? In this instance, I just want it to print onto a person's screen saying that this number is positive. So you indent this because that's how the code would be written, but we'll get to that later. But I'm just trying to introduce the concept of pseudocode. You write print positive. So that essentially is just detailing, if this number is greater than 0, let the user know that it's positive. The next thing is if less than 0, print negative. And that's it. That's the two things our code should do. If you want, you can add a third element in for if the number 0, what you want it to write. I won't put that in here, but you can add that. It's just a third if statement. And then what do we want the program to do? Well, we basically just want it to end. It's done what it's designed for. So I would just write here, end. That is essentially the pseudocode for our first program. That's it. There's nothing more to the concept. If you're ever beginning with programming, the first thing you should do is treat it like a recipe. Write what you want to achieve and basically just write it out in plain English like that. No matter how complex a program is, I always write it out in pseudo, because then I can refer to that and say what step of the process am I currently in and how can I build from that. So moving on to the second concept, what we're going to be doing here is something called control flow. So what control flow is a way of, it's how the program is basically being read. You obviously this is probably the simplest concept around. So when you write code, it's basically following a downward structure. That's called control flow. So in this instance, control flow essentially looks like this. So this box represents a chunk of code. So I write predecessor. Next thing is we're going to have our, so what's the next thing that normally comes after predecessor? You have a operation. And after the operation, you have a successor. Those three boxes outline the outline of a program. You have a predecessor code, you have an operation that's currently going on, and then you have a successor, which is basically what's coming next. That's the simplest concept around. That's all code is. You write something, it does something else, and it continues until it hits the bottom where it might end the program, for example. The next thing that we're going to be basically looking at is called selection. Selection is what we just did in our pseudocode there, where we wrote if something, if that. If I say this, do you want it to do this instead of this, or, etc., etc. So what we're going to do here is I'll draw out the diagram for selection. So the way this basically looks is it's very simple. Use a triangle to represent when something's branching. So you have your predecessor again. I'm just going to write pre. I'll be here all day. Pre. This then goes to a condition, which is this triangle. Condition. Now, this condition normally has two outcomes. It's either a yes or a no. So it's a true or false, yes or no, basically. If this thing is true, let's refer to our example. If the number is greater than 0, I want it to do this. And then you'd include your code there for what it's going to do. However, if the condition says no, what do you want it to do? So what I want it to do is circumvent this initial block and run this block down here. So this top one here is Y, that one's N. If something is true, run that. If not, go around it. Regardless, once Y is finished, it always goes to N anyway. It's the structure of the code. If something, go straight down to the next block and run that. If not, go around that and go to whatever's coming up next. So this, in this instance, is the operation, and this is the successor. And those two concepts are essentially what most programs are. You got your flow straight down, and you have a bunch of conditions. If do this, if do that. AI, for example, is just if a user says, Alexa, for example, what's following, do this, do that. These are the basic principles of computing, and it's good to know these. So the next thing we're going to be moving on to is called iteration. So we're flying through these pretty quickly, but they're pretty simple concepts, and for that reason, it's pretty easy on how to understand them. So what iteration is there's two types of iteration. You have for loops and while loops. Well, you have do whiles as well, but we'll get to that at a later stage. So what a for loop essentially is for X period, let's just say, do these objectives, sorry. Or while this statement is true or false, do these statements. It's a way of repeating the same task over and over again. An example is, say you wanted a application that would count to 10. You could write each line as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But that's a bit long-winded and it's a waste of time when you can do it in essentially what is one line. So you would write 4 X numbers while it is less than 10. Do this, and that would just be print the number that it's currently on, and that would go all the way up to 10 and stop. Don't worry about that concept, we'll visit that in our for loops video, but this is basically the structure these for loops follow. So same thing applies again. We're going to have a predecessor that goes first. This is a block of code that just runs. The next thing we have is so in this example is we'll have a condition. So I'll just call that cond. So if this condition is met, what do we want the program to do? We basically want it to run this block of code down here, which could be our calculation. So that's obviously the operation. Cool. Once the operation is complete, what do we do? Well, we have to go back to the condition because this is an iteration. Sorry. So we would go back up here, and that's that. That, as you can see from the drawing, is already a loop. It's just going to keep going round in circles until something breaks. What happens when it breaks? That's the question, right? When this code breaks, what it wants it to do is go out this way to where n is. So we'll just label this as y and n again. You know, if it's always true, aka y in this instance, keep doing this thing. If not, just come over here and we've basically got the successor. So let's put suc. That's the successor. So that's the code that's running after this block is basically finished. That is essentially what a for loop is, and it's as simple as that. So there's another type of statement, I guess, that will run. So the other iterative look, I guess, is the best way of describing it, is this. So difference there is the condition was straight away afterwards before. Now we're going to be running this statement. And the statement will be followed up by the condition. After the condition, we're basically going to loop back all the way around above. And that's our y. And then our n is off to the side here, and that's the start. That is another type of iterative loop where the statement is coming before anything else happens. The statement runs and then it checks if the requirements are met. If the requirements are met, then it won't loop again and it would just exit. If they're not met, it might loop again. These are the concepts behind what the code you'll be writing later in the course. So that's how iteration basically works. And now we're going to be moving on to the second to last segment, which is basically called calls. Well, they're called calls, as annoying as that sounds. What calls are a way of referring to other areas of the code while you're in one segment. So the way this basically works is, you know, this is a fairly simple concept in itself. You have your predecessor, you'd go down here, in here, instead of a condition, I have a call. So what a call is going to do is reference an area elsewhere on the page. So that will then come out over here, where I might have another segment of code essentially. The call is similar to a link. You know, I'm reading this page currently. There's a segment right here which refers to another page somewhere else. I click that, it would access this, and I get to see it. Same thing applies. This link essentially joins another bit of code into this area. And then after that block of code's basically run, the call is then, obviously, it has a successor. That is what a call is. It's just referencing somewhere else, using that area of code, and then coming back to the main body of the code. You'll see these references in Java or Python, and it's a pretty useful way of making your code look neat, because if you were to run the application, the control flow would only be the left-hand side. You know, the stuff that you're seeing here is what the control flow will be, and then this code is elsewhere. So those several concepts I've just mentioned are the basis of what computer science is. You know, programming, if you understand these 4 concepts I think I've mentioned, you should be fine when we get to learning how to code. We'll be learning in Python, but there will be a course arriving in Java. So the first thing I'm going to do once again is going to be the new idea of variables. So what variables are is, you know, when we were doing that example of get the number and all this, where do I put that number? So imagine yourself a bunch of boxes like this. So these boxes are where data is stored. In the first box, let's call this first box the letter X. And I want to call my next box A and the next box B. In this example, I'm going to do an addition. The addition is going to be A plus B equals X. So how do I get to that? If you want to know, you've got these boxes here on the left. In A, I want to assign a number. Let's just say 3. A now refers to 3. The way this is written is A equals 3. Simple, right? The next thing is B. B is going to be assigned 2. B equals 2. You can see where I'm going with this, right? Well, if I have A and B as 3 and 2, that's essentially 3 plus 2 equals X. Well, X is 5, and in this example, I'm going to put 5 to that. And that's basically a program in itself, actually. You know, if I took this out and I wrote A equals 3, B equals 2, A plus B, well, you'd have to write it this way, but X is equal to A plus B, and then, well, that's basically it. That's the 3 lines for the addition of how a program essentially works. That is all variables are. You know, it's not the hardest. It's one of the things that people always get confused on is, how do I assign things, or where is things actually being put? Imagine it like that, a bunch of boxes. You put something in the box and you give it a name. You know, labeling. You go to a shelf, what's the label on the shelf? What's inside that shelf? That's all it is for these. And that's basically everything that needs to be covered in this concepts of computer science, I guess, or programming. We're going to be moving on to Python firstly, so that video should be out on 2 to 3 days, depending on what release schedule I've decided. But yeah, so thank you guys for watching this video. I hope you've enjoyed it. I know it was a bit long, but these concepts are boring, and once we've got through them, we can actually get to coding and actually programming useful stuff. If you have any questions, just leave them in the comments. I'll get back to you, or just reach out to me and I'll get to answering your questions as well. So thanks guys for watching. I hope you will have a lovely year ahead. See you guys.